Okay, let's to start with task 1. Subtask A, you have a power system, figure 1. There is a 3-phase generator here, connected turbine, supplying a motor. Generator, the rated, the voltage, and the impedance of the motor, and the impedance of the line is available. The voltage on different side of transformer is available, the rating, the reactance, and the reference voltage, the bus bus voltage consider as a reference, and the S base and the V base. So yeah, it can be useful to summarize what are the inputs. From the generator, we know that according to the text, we know that what's the rating. The generator 100 MVA is a rating, 11 kilovolt is the voltage of generator. Regarding transformer, we know that what's the type of connection, delta, left side, and the start on the right side, the voltage on both winding we have, and the rating, the MVA 125 megavolt ampere and 8%. And this one is impedance of the line, but this one is in ohm. You have to convert in per unit in future. And these are the input for the load. What's the impedance of in ohm of load, and the angle of the load, and the voltage of load. And according to the text, we know that the base value are 100 MVA for the S base and 110 for voltage base. And the reference, this bus is considered as a reference, its voltage is considered as a reference 1 per unit, the amplitude of the voltage and the angle 0. So the first part, we have to draw the equivalent circuit. And we know that the equivalent of this circuit will be this one. You have a generator that we have a voltage source, transformer, reactance of transformer. This one is the ideal transformer to step up the voltage, the impedance of the line, and this one, the impedance of the load. So we have the per phase equivalent circuit. However, in subtask 2, we have to calculate the currents IA, B, and C on the load side here. According to the input data, we know that the impedance of the load, the amplitude of impedance is 150. However, it is in ohm, and you have to convert to the per unit. And you know that how to convert an impedance to per unit. Yeah. If you have an impedance in ohm, if you divide to Z base, you can calculate the impedance in per unit. So we know that this one is impedance of the load, and we divide to Z base. If we divide it by Z base, we can calculate the impedance in per unit. And you know that the Z base is voltage square over S base. It's a formula we use for the calculation of impedance base value. Okay, so To calculate the current, you know that the current will be voltage in per unit over impedance in per unit. Current will be in per unit. So the voltage of load, you can see here, according to the text of the task, is the reference value. 1 with the angle 0, and this one, amplitude is calculated here. The amplitude of impedance of the load in per unit, and this angle got from here, according to the text. So if you divide voltage by the impedance, you can calculate the current of motor. And the current in phase A is calculated. However, for phase B, you have just 30 degrees phase shift. And you know that the angle of current, phase B, is the angle of current, phase A, minus 120 degrees. And for phase C, you know that current, angle of current, phase A, plus 120 degrees. Based on these formulas, you can calculate the currents on other phases. Okay. However, another subtask asks us to calculate the current on the other side of circuit, the current from the generator side. From the previous result, we know that the current here, current in phase A, B, and C. In order to calculate the current on the other side of transformer, since your previous calculation was in per unit, the only change is related to the phase shift from one side of transformer to another side. So in the previous task, we calculate IA here. And if you want to calculate current from the other side, the amplitude will not change. But the angle, we have a phase shift from one side to another side. Since the type of connection is star from the right side to delta to the left side, we have minus 30 degrees shift in angle of current, but the amplitude will not change. We have the same procedure for the phase B and for the phase C. You can see this phase angle, 30 degrees phase angle shift, is because of the transformer, the type of connection. The second part of the task asks us for voltage terminal. What's the voltage here? And in order to calculate the voltage, you have current and you need the whole impedance that this current through the route. And according to the input, we know that the transformer impedance is 8%. However, this 8% is calculated based off 125 MVA. However, the task asks us to consider 100 MVA as a base case. So we have to convert the 8% to new value. And you know that if you want to convert the X new is X old multiply S base new divided by S base old. According to this formula, we calculate new value for the impedance for the reactance of transformer and the impedance of the load. This value is in per unit, is in ohm, and you have to convert to per unit. And we know that how to convert in per unit. The impedance in ohm should be divided by the Z base. That is voltage squared over S base. So now we know that what's the total impedance of the system. And according to equivalent circuit of the system, we can calculate the voltage here. The voltage will be the voltage of the load that is transferred to other side of transformer, and that one is minus 30 degrees is because of the type of connection of transformer. And this one is the current of phase A, the approximate value. And this one is the whole impedance you have in the transmission line. It's the impedance of transformer plus impedance of the line. Impedance of transformer and the impedance of the line. Okay, the last part is related to active and reactive power and the power factor. Okay, so from the previous task, we calculated the voltage here and the current in the circuit. And we know that the complex power will be the voltage times currents, conjugate of currents. The complex power in per unit can be calculated based on this formula. And we know that the real part of complex power is active power and the imaginary part is reactive power. However, this one is in per unit. In order to convert to the megawatts, you have to multiply the per unit of the active power to the base of power. And the power factor, according to this figure, we know that this one is active power, reactive power, and S complex. And this angle, that is the cosine, is power factor. At this one will be active power over amplitude of S, apparent power. And based on this formula, you can calculate the power factor.